Good morning, ladies and gentlemen. Welcome to the first of our tracks for VulnCon. I'm Krobe. You'll see me wandering around here throughout the week. I am super pleased to introduce my friend Andrew. He's one of the maintainers of a project called OSV. That's very important within the open source ecosystem. He also works for Ghost. So a few announcements. There are session surveys. We'd like to hear your feedback on how the conference is going and how particular speakers are. So at the end of the session, there's some QR codes that we will assure you are totally legit. So you're safe to go ahead and click them. So please give our speakers feedback, give the conference feedback after each session. We would like to ask everyone with cell phones, as a courtesy to the speakers and your other audience members, silence them so we don't get interruptions. Also note that we are live streaming. There's a camera in the back of the room. So Andrew has asked that we take questions after at the end, and I'll wander around with the microphone, and I'd like Andrew to repeat the question so our friends on the internet have the ability to have the same experience that you all here in IRL have. And with that, my friend Andrew is ready to talk to us about the trials and tribulations of bulk converting CVEs to OSV. Thank you.
The trip hazards out of the way. This is on? Okay. Can't hear myself. I'll start this with a preface. In the grand scheme of the CVE program, I am but a noob, a new entrant. So this is my perspective of that sort of newcomer experience. I can appreciate that given the age of the space, there are many perspectives. I'd be interested in your take on things in the Q&A or afterwards in the hallway track. So I'm a real mission statement kind of person. I figure it's what the wrapper says about the contents. It's the North Star for an organization or a program of work. I'm going to keep coming back to the CVE program's mission statement in terms of being its self-described purpose, its reason for existence, its idea of what good enough looks like, and challenge folks to think more deeply about the why behind it. Ever since I read Simon Sinek's Start With Why, I've realized the importance of having a really clear understanding of the why, particularly in work contexts. So my explicit question in response to this mission statement is, and then what? Or more succinctly, why? The 5 whys technique is a great way of really getting to the root of things. So if I were to rhetorically ask why to that mission statement, we might arrive at answers like the one that I most regularly hear. So there's a unique identifier for vulnerabilities. Cool. That'd be the identifier part of the mission statement. Why is this so important? Maybe it's so everyone realizes they're talking about the same vulnerability. But why are they talking about it in the first place? So people can prioritize the response. Sorry, it helps with the prioritization of response if everyone's already on the same page about what it is they're needing to prioritize the response to. And that response could be eliminating the risk by upgrading, eliminating the risk by mitigation, or maybe it's accepting the risk, or maybe there's no risk at all. But why does the response need to be prioritized? Because vulnerabilities have security implications. And oftentimes there's more than one to be dealing with at any point in time. So here's an example, no pun intended. It's in a piece of software called Ghost. In this case, there's no usable version information available in this particular CVE record. So unfortunately, this isn't programmatically actionable by a consumer of this record. Frustratingly, there is version information in the human readable description of the CVE record. So it would have been straightforward to construct a usable affected entry when authoring the CVE record. So if we come back to this mission statement, I personally don't feel that it's speaking to the ultimate reason of why the CVE program is seeking to identify, define, and catalog publicly disclosed cybersecurity vulnerabilities. Or maybe it's just that the minimum standard of define isn't where it needs to be. It's very easy to say that the job is done once the CVE ID is issued. Hey, it's identified, and a human readable description exists. Hey, it's defined, right? And to focus on how many IDs are issued or reserved in a year, or a bunch of other very basic metrics around pure count of records as mission accomplished. Having spent far too much time in the past 18 months programmatically looking at CVE records in aggregate, I'm standing here today suggesting that the CVE program and CNAs creating CVE records would be better serving their downstream users if they were thinking beyond things like CNA growth and a quantity over quality approach to CVE records, and to be focusing on what I believe is the ultimate end goal of a CVE record, helping users of them to reason about them at scale, enabling affected users to sustainably deal with the vulnerability it refers to by programmatic means. This means going way further than human readable descriptions when everything and everyone is dealing with year-over-year growth of CVEs like we see here. So my take on fitness for purpose goes beyond just having a unique identifier for a vulnerability and a detailed human readable description, and allowing consumers to definitively know if they're impacted and what their next steps should be. So my call to action for CNAs is to focus on the aggregate programmatic use of your records by their end users. And for the CVE program more broadly, make it easier for CNAs to do the right thing and harder for them to do the wrong thing. So g'day, I'm Andrew. I'm a software engineer on Google's open source security team, or Ghost as we like to call ourselves. I work on OSV along with my 4 other colleagues and my manager in Australia. And I've had the privilege of being able to work at Google in 2 countries for almost 2 decades, and the opportunity to experience a variety of engineering roles during that time. I was hired in as a Linux systems administrator, and then I became a site reliability engineer, security engineer, and now I'm a software engineer. I'm really, really grateful for the opportunities and the broad perspective that these experiences have given me. Before I joined Google, I was working in the internet and managed services security provider industries in Australia, in Brisbane and Canberra. I currently work from home in Brisbane in sunny Queensland, and the rest of the OSV team works down in Sydney. Some fun facts about Australia. We're in the future. That makes our Mondays delightful because the US is still having its Sunday. So we get a no meeting day every week. As I said, I live in Queensland, where we're 1 hour and 30 years behind the rest of the East Coast all year round. This means that most of the CVE program working group meetings are at 6 or 7 a.m. my time, which makes them a little awkward to regularly participate in. Joys of the world being around. Come on down for a visit. We have an excellent cybersecurity conference scene. Just make sure you watch out for the drop tests. Okay, so let's dive in. Firstly, a bit of background context in case you're unfamiliar with what OSV is. Since I'm banging on about mission statements, here's ours. We want to enable developers to reduce security risk arising from known vulnerabilities in open source software components that they use. The problem that OSV seeks to solve is one of precisely identifying vulnerabilities in open source software in particular, and to make that information universally accessible and useful. Sound familiar? What's our why? To enable prioritized vulnerability remediation for the vulnerabilities that actually matter. That might seem like a convenient carve out from the broader CVE problem space, and it is to a degree. It's still a pretty gnarly problem space on its own for at least some of the usual reasons that we all know and love, which I'll talk more about today. OSV was born out of the desire to capture information about the vulnerabilities that OSS Fuzz was finding when it fuzz tested open source software. At the time, the CVE schema was at version 4, which didn't allow for the precision that the OSV schema and CVE5 do today. OSS Fuzz is all about source code in Git repositories and Git revisions. And CPEs don't naturally correlate well with Git repositories. So a lightweight schema that catered specifically to this need was created. I think the process of getting CVE IDs was too slow at the time, and the idea of programmatically generated vulnerability records being automatically submitted to the CVE list also gave some people the heebie-jeebies. There was the potential for overlapping of scope and all of that sort of history, but that was all before my time joining the project. So rather than limit the use of the OSV schema to findings made by OSS Fuzz, which today is fuzzing over 1,000 open source projects, the schema was socialized to other open source language projects, starting with Go and PyPy, and saw some early wins with adoption there. When the OpenSSF was being created, Google donated the OSV schema to it. OSV.dev and OSV Scanner are Google sponsored open source projects. And we operate OSV.dev as a public service. So, fun fact, the OSV schema had some direct influence on the utility of the CVE5 schema when it was in development, adding richer version semantics to the affected field. Theoretically, there's interoperability between CVE5 and OSV, and this is an area of personal interest to me, where I'd like to see that theoretically become proven with official tooling to allow for easy direct conversion between the two formats. So that initial adoption has organically snowballed to where things are today, with over 20 ecosystems now publishing vulnerabilities in the format and being imported by OSV.dev. OSV.dev serves as a central aggregator of the data, performing automated enrichment of it and a human-friendly web interface and a machine-friendly API. Today, OSV's value proposition is vulnerability information that is both about open source software and is open source itself. It is focused on being actionable by its consumers, developers, and related interested parties who are needing to manage a never-ending stream of vulnerabilities in the open source software they're using. First-party applications like OSV Scanner and a growing number of third-party integrations like Tribby, Renovate, and Dependency Track use the vulnerability data available via OSV.dev's API to scan source code vulnerabilities and container images for known vulnerabilities in dependencies. OSV Scanner also has experimental support for identifying vended or embedded dependency source code, and this year is improving its container image scanning capabilities. The strategy moving forward is around data and client-side tooling. On the data side, which is my area of interest, we're building out a scalable data quality story, which I'll touch on at the end, and looking to increase the number of language ecosystems providing symbol-level vulnerability detail. On the client-side tooling side, it's extending OSV Scanner's capabilities, enabling earlier integration into the development lifecycle so that known vulnerabilities don't unintentionally ship in the first place, and adding additional record management tooling. The ultimate goal is to enable an end-to-end vulnerability management solution for consumers of open source software with a bias towards modern application development practices and technologies. A quick overview of OSV.dev's infrastructure. The infrastructure all runs on Google Cloud and operates on a pull model. Distributed databases publishing in the OSV format can publish records via a Git repository, a public GCS bucket, or an unauthenticated REST API. And OSV.dev's importer regularly pulls from these sources. During record import, enumeration of affected versions and commit ranges is performed for efficient future lookups by the API. And these enriched records are periodically exported back to a public GCS bucket. So where my work intersects with the existing CVE ecosystem is around our desire to close the gap on C and C++ vulnerabilities specifically. So unlike more modern languages like Go, Python, and Rust that all have central package repositories and a centralized vulnerability reporting mechanism to go with them, C and C++ do not. This leaves us relying on programmatically converting existing CVEs in open source software as best as possible to supplement the OSV.dev database. Rather than focus on the programming language a CVE relates to, we've just focused on the open source software part, as there's no downside to successfully converting more CVEs than less. We're using the fact that having a known Git repository is a proxy for relating to open source software. When we started this project, CVE5 hadn't yet landed, and the NVD seemed like the sensible aggregation point to obtain the most enriched CVE data. given the uniform addition of CPE strings and other applicability information that made the CVE records in the NVD richer than in the CVE list. In addition, the NVD also has this treasure trove of related metadata, the CPE dictionary. Enter the first challenge, trying to definitively identify the canonical repository for a CPE vendor product combination. Git repository URLs pop up directly as references in individual CVE records and indirectly via the CPE dictionary as metadata. We're pre-processing the CPE dictionary to produce a simple mapping between CPE vendor product combinations and what we presume to be the canonical repository. The first preference is to use these pre-computed repositories for the CPE vendor product combinations and falling back to references on the individual CVE when that doesn't work out. This is challenging because there are plenty of valid looking Git repositories that aren't the Git repository. Often they're a vulnerability researcher's repository with some disclosure content or a proof of concept exploit code, and are most definitely not the droids that we're looking for. Today, this requires maintaining an ever-growing deny list of these are not the droids you're looking for repositories to help with the accuracy of measuring that 100% target that we're shooting for, and also to reduce accidentally successful conversions. So here's a sampling of the mapping that's being produced. We've just got the vendor product combination as a key and one or more repository URLs as the value. The problem with using the CPE dictionary as the primary source of truth is it's not as comprehensive as it could be. It's reactively populated when a vulnerability is first found in a piece of software. There isn't always good repository metadata for a given CPE vendor product combination, although fortunately public contributions improving this are readily accepted. We've been providing feedback on the CPE dictionary to the NVD on an ad hoc basis based on manual analysis of our conversion results, and it's been really pleasing to see those that feedback incorporated. I've also recently become aware of ScanOSS's Perl to CPE repo. That was a late-breaking discovery. I've done some spot checks, and I haven't found that it revealed any significant addition in coverage. I think they're also using the CPE dictionary as their source of truth. One of the downsides to this approach is it presently requires this manually curated, ever-growing deny list of known garbage repos to ignore. While this is not particularly difficult or time-consuming to maintain, it is more of an ongoing maintenance burden than we'd like long-term. And then the one thing that did catch us out of left field was the NVD's recent increase in analysis latency that I think we all know about. This means, amongst other things, that applicability statements, including versions and CPE strings, aren't being added to new CVEs at the same rate, and new entries aren't being added to the CPE dictionary. As a result, this significantly reduces the timely effectiveness of the conversion process. For CVE records yet to be analyzed, purely the CVE references are being relied on for fixed commits and to signal that a CVE record is even in scope for conversion. So OSV records have introduced versions, fixed versions, and less preferred, a last known affected version. They also have the same for Git commits. We prefer an explicit fixed version over a last affected version because in the interest of avoiding false positives, the schema makes the assumption that the next version after the last affected version carries a fix for the vulnerability, which can result in false negatives. Philosophically, the OSV schema made the call to prefer false negatives over false positives, where having to make that call is the unavoidable outcome. Ultimately, particularly for C and C++, we want commits because the use case is scanning a Git repository at a particular commit. Sometimes we get handed a presumed fixed commit URL on a potential platter in the form of a reference to the CVE on the CVE that is a Git commit URL. But more often than not, we've got random version numbers from the metadata or description. And so it's left as an exercise to extract them for subsequent attempted mapping to commits. We can pull versions from the applicability statement in the structured metadata, or less ideally from the CPE string itself. And even less ideally from the description text. Here's an example using the most preferred way, using the richer description expressions available in the applicability statement. Here's an example using the version straight from the CPE string. It's less ideal because all it provides is a known vulnerable version number with nothing definitive about a fixed version. And here's the least preferred technique, relying on the description text for the version information and references for the repository, because the CVE record hasn't been enriched by the MVD yet. So getting from what we've got to what we want. As I said, the unit of measure for what we want ultimately is a git commit. So unless there happened to be a commit URL as a reference, which is then assumed to be a fixed commit, the next challenge is trying to map those version numbers to commits in the Git repository. This is done by remotely examining the tags in the selected Git repository and performing some fuzzy matching where necessary to map the versions of interest to the commits for the corresponding tags. This only works as well as the release practices of the repository. And that assumes that we've even got the right repository. So for the previous 3 example CVEs, where version numbers and repos were derived, this is essentially what happens, the moral equivalent of a Git ls remote, looking at the tags. The downside of grabbing the commit hash directly from the CVE's references is that having a commit hash doesn't always mean it's the commit hash. When OSV.dev processes a new or updated record, it enumerates all of the affected versions for it. And where a Git repository is involved, it clones the repository and enumerates all of the affected commits as well. Doing this makes it very simple and straightforward for the OSV.dev API to make a determination if a specific version or commit hash is affected by the vulnerability. The analysis performed as part of commit enumeration falls over badly if the affected commit it's looking for isn't in the repository that it's looking in. So this happens when the commit hash relates to a fork. This is where I find out the slides don't work properly. There we go. Yay, what? Using commit references from the actual repository and not a random fork of it would be really fantastic in these sorts of scenarios. Coming back to our 3 example CVEs again, here's the end result. This one had clearly defined introduced and fixed version information in the applicability statement. Note that this translated to introduced and fixed commits. This one had the known affected version and nothing else. So we've had to resort to using the last affected instead of a fixed. And we have no idea when it was introduced. So we assume everything before it was vulnerable. And this final one is essentially the same as the previous one. We just arrived at it from a different source. So for some dazzling metrics, on the pre-computation side, we're seeing almost 10,000 product vendor combinations from the CPE dictionary with computed repositories, with closer to 9,000 unique repository URLs in that set. And despite all of the aforementioned challenges and caveats, the conversion rates we're currently seeing are ranging around the high 60th percentile at the moment. So there's further work that can be done and is yet to be evaluated for return on effort, but some possibilities include taking the GitHub pull request URL that is in a reference and using the GitHub API to resolve it to the underlying commit. looking up the pull request from a GitHub issue that is cited as a reference, and using the GitHub API to dig around in that to find the pull request that closed it, and looking for the same sorts of things from other Git hosting providers where it makes sense to do so. This is where I get my wish list out. So if I could wave my magic wand, well, for starters, software would be being developed in secure by default in memory safe languages, and we wouldn't be having this conversation. We'd be sipping pina coladas on the beach somewhere in far north Queensland. That said, we've all got jobs for life at this stage. So the NVD would be outputting records in CVE5. I have no doubt this is going to happen eventually. It'll be great for everyone when they do, because it will mean they're able to pass through higher fidelity information from the original CVE5 record instead of essentially translating it into the NVD's dialect of CVE4. On the input side, CNAs would uniformly populate their CVE5 records to a higher standard than currently. They would be supplying CPE strings where they're already defined. The versions that are in the description would also be in the machine readable fields. Canonical source repository links would also be supplied in the affected field. This is a field for that. The schema would do some validation on the way in so that that quality bar is being enforced. And there'd also be some non-blocking warnings to sort of nudge people towards best practices. And separately, from an authoring perspective, if the GitHub commits actually belong in the repo that they for the canonical software, that'd be super. And more broadly, there'd be a comprehensive, decentralized, open data way to map between CPEs, Perls, and the canonical Git repository for a particular piece of open source software. To focus on a few bright spots for a moment to illustrate where things are looking promising, here's the CVE from this year. And here's a great example of the sort of version information that makes this immediately more useful. This one was my personal favorite that I found while I was looking around for some good examples until I looked at it more closely. Not only does it have well-populated version information, it's also got the source repository as well. Although guess what? 16.8 isn't a valid Semper version. Boo. Another CNA doing amazing stuff is the newly added Linux kernel. I know this is a bit of a controversial one. I know for mere mortals who aren't Linux kernel internals familiar, myself included, the human readable descriptions like this might look really daunting, but take a look at the metadata. This is a thing of beauty when it comes to allowing for potentially programmatically determining if impacted. To bring us back to what I said at the beginning, due to the highly federated nature of the CVE program today, without adequate centralized quality control, downstream users cannot reliably reason about CVE records at the scale necessary to utilize them effectively. The CNA that creates and owns a given record is of no particular relevance to them. It's an implementation detail. It doesn't matter to a downstream CVE consumer if one CNA is being amazing and another is less so, if the overall consistency of the records collectively aren't meeting their needs. Consistency, irrespective of CNA, really is key here to the CVE records being broadly usable by downstream consumers. And I can appreciate that this is coming from the perspective of myself looking at these programmatically in bulk, in aggregate. And I'm also aware that there's other perspectives around the why these things get created, right? It's not just about the consumer side. Sometimes it's about the researcher side as well. Here's what OSV.dev is doing in 2024 to up-level our data quality story. We want to make it easy to shift the problem of data quality further left in the vulnerability record lifecycle by having tooling that allows for validating a record before it gets committed to a Git repository or part of a pipeline to copy to a GCS bucket. We're going to define a machine-readable way for our data source providers to reason about records that don't pass validation when OSV.dev attempts to import them. Then we're going to turn on schema validation and provide a machine-readable report of which records don't import successfully, which will include why. Known import failures will be surfaced to OSV.dev users via the website or API so that they understand why they can't find them. And we'll also be minimizing what I call the don't shoot the messenger problem. Just like the NVD, where there's a perception that a CVE starts and finishes with them, we're already seeing this with vulnerability records that are surfaced in OSV.dev that originate from one of our upstream sources. We're a small team and there's no value add in us being in the middle of a conversation between a downstream user and one of our upstream data sources. So we want to make it as transparent as possible to our users how to provide direct feedback about specific records. So if you're interested in collaborating with us, we have representation at the monthly APAC-friendly OpenSSF Vulnerability Disclosures Working Group meeting, chaired by the fabulous Krug. And you can also reach us via our discussion list or the OpenSSF Slack. And these are the relevant GitHub repos that we're operating in. And that's the end of my prepared remarks. If you want to have any questions, I'm all ears.
Thank you, Andrew. Does anyone in the room have questions about what Andrew's describing? Oh, in the front row, and then I'll come back here.
Feelings, reactions.
I have so many questions because I think this is super great.
Thank
We're good. So the first one you talked about like 100% of open source vulnerabilities since 2016.
Mhm.
I've pulled your data, but I haven't dug in deep. Or do you have stuff that's not in NVD and MITRE? So I'm curious if some of those alertings haven't actually gotten an ID for whatever reason, and if you've done any analysis there.
Okay, so the question, to repeat for the remote folks who hopefully heard it anyway, but was basically 100% of open source. What about the ones that aren't CVEs? In a nutshell, yeah. So that comes into that 20 plus ecosystems that we've already got natively as in the OSV format. There is definitely a delta between what we're getting via CVEs and what we've got via other sources. The OSV schema has this concept of aliases. And so there is linkage between, say, a GitHub security advisory that did not also result in a CVE and ones that did. So there's always the unknown problem. So you know, can't really say about the ones that don't exist at all, but there's definitely a superset of CVEs. Yeah.
Hello.
Hi.
Has there been any thought about extending this beyond OSS into like IoT hardware or thing vulnerabilities that aren't open source?
So the question was, has there been any thought about extending it beyond open source? Yes. There's a general desire to not twist or overcomplicate the schema into areas that would undermine its reason for existence in the first place. So it's come up in conversation with like ENISA needing or wanting to have their own vulnerability database, for example, and so people have said, well, can OSV do it? And the answer is maybe not, because that would proprietary software if we look at what CVEs relate to, they can relate to hardware, operating systems, and software, and proprietary software and open source software. Trying to jam all of that into the schema in its current form may or may not work well. There's nothing stopping it being done, but we would be hesitant to want the schema to evolve in ways that make it no longer as fit for purpose for what it is intended for.
Any additional questions?
So you spoke about the
your focus on finding the canonical repo for a piece of software. I wonder about what your kind of philosophical position is about when there are multiple canonical repos for software. Like if I think of a piece of Python code, right? You could get that from PyPI, you could get that from Red Hat, you could get that from Ubuntu and so on. And for each consumer, the canonical one is the one that they're getting it from, right? And the same CVE will appear in different places and might be fixed in different versions as well when we fork and all that kind of complication. So you seemed very focused on having one canonical repo. I just wonder how you how you think about that multiplication problem.
So, and I'm chuckling because the guy from Canonical asked the question about canonical repos, right? Well played. The question was, what do we do about more than one canonical repo? And we support that. If we're able to identify more than one repo, you may have recalled that example. One of those CP product vendor combos had more than one repo. We poke around in all of them to try and map the versions to commits. So, and then the OSV record that's generated will reference all the ones that it was able to convert a commit to, version to a commit to.
Any additional questions?
What are we doing for remote questions out of interest, Probe? Okay, so if they're asking questions in the Discord, I'm being a remote worker myself, I like to be inclusive. So,
okay.
Hello.
Hello. I promise you a question. Thanks once again for this presentation. I would like to get back to the first question and extend it a little bit. What is your opinion about vulnerabilities that are reported, but without official CVE record, without official CVE ID? Because what is your opinion? How to handle it? Should we practically assign something?
So the question was, what is my opinion about vulnerabilities that are reported without a CVE ID in particular getting assigned to it? This is an interesting one, right? Like, yeah, opinions. I'm full of opinions. Opinions are like armpits. Some of them stink. It's okay. So if you look at the benefit of there being a CVE ID, in terms of there being one global identifier to talk about the thing, then yeah, there's a downside to there not being an ID with a CVE prefix, right? OSV has decentralized the identifier space, right? So every ecosystem, when it stands itself up, reserves itself a prefix. So, GitHub security advisories start with GHSA, for example. Go vulnerabilities start with Go. So I guess if people want to speak a common prefixed language, then yeah, there has to be a CVE issued, and then you can sort of say that this Go vulnerability or this GHSA is also known as CVE, whatever. And I guess a lot of times what we're seeing now is the record source providers that are giving us OSV records are also CNAs. So for example, the GitHub advisory database is also a CNA. Go is also a CNA. The Python Software Foundation has just become a CNA. Curl's a CNA. It's becoming more and more a case of, I think, open source projects that are at a certain maturity level appreciate the value of being able to control a narrative around their own vulnerability disclosures. And so there's a bit of a snowballing effect, I think, happening where they're becoming a CNA and they're also choosing to become an OSV data provider as well. So I think that the phenomenon might go away moving forward because they're publishing both. And I guess there's always the way to request a CVE reactively to the existence of a vulnerability record that's not already got a CVE ID. Does that answer the question adequately? Thank you.
Any additional questions here in the room? Ooh.
Yeah, thanks for the great talk. What's your opinion on CSAF? Would that add value somehow?
CSAF.
CSAF, yes.
The our feeling on CSAF as a format is it's more complex. It's a far more complex standard, right? Like if you compare the definition of the OSV schema with the definition of the CSAF schema, like much more complex definition, right? And I think again, like CVE5, it's trying to cover a lot more use cases than just open source. And so I don't like getting bogged down in what I sort of call tyranny of awe arguments about why not this, why not that, right? I'm a why not both, or why not all of them, or and so at the end of the day, a lot of these all of these formats are just JSON, right? And so if there's a good conversion story between them, then we don't have to get bogged down in this tyranny of awe argument about why not this, why not that. Master it in whatever floats your boat, and then convert it or publish it in all of them. And then everybody wins. They can use it where they're at. And, you know, if we're focusing on why are you doing this so that you can help your users remediate their vulnerabilities, they can consume them however is most comfortable for them, right? So I would love to see it possible to convert an OSV record to a CSAF formatted VEX record.
Perfect, thanks.
We have one question online so far from Veixel Gartner. Is it possible to map between Git commits and C++ package managers like Conan or VSP package, or do you have plans to support those ecosystems?
Funny you should ask. We just had a bug come in the other day. Someone's playing around with OSV Scanner. OSV Scanner supports Conan lock files today, but we do not have a known data source for Conan vulnerabilities, which we're actively exploring at the moment. So you know, the answer is if we can get a source of vulnerabilities, then we can scan Conan. I'm not familiar with the other one. Say it was VPS or something like that. Yeah, I'm not familiar with that one. If that person would like to file a GitHub issue, either in the schema to have it supported by the schema, or in OSV.dev to be added as a source, and or in OSV Scanner to be supported as a lock file format. If there's a lock file format involved, then we will cheerfully look into it.
So patches are welcome.
Patches are welcome, and if you don't want to give us a patch, at least give us an issue that's well written.
Any additional questions in the room or online? All right, Martin,
Just run for it. Make it fast.
Hey, Andrew, thanks for the presentation. It was great.
You're welcome.
What's your selling point to the CNAs to improve their security metadata? Because I think everybody in this room agrees that better metadata around vulnerabilities is a good thing. But how do you go to a CNA that doesn't quite care about this space and tell them like, hey, publish better data?
Right. And that's the interesting extra perspective on this, right? Like we've got, I talked about our why or my take on the why for CVEs existing. And something I've had my eyes open to just last week was that, there's also a different why out there for some CNAs as to why they're publishing CVEs. And what I got my eyes open to was that, it's the vulnerability researcher that wants the CVE as a kudos, as a feather in their cap. And so they're potentially only focused on the human readable description and not the machine readable part, right? And so I think where there's an overlapping of incentives, right? Like where the CNA is a vendor, you've got probably the best of overlapping of incentives, because the vendor ideally you would hope is wanting to do the best possible thing by their users. So they're writing for their users as much as they're writing to placate the vulnerability researcher's desire for bragging rights. And then that's where I sort of talk about I think we've got to raise the minimum standard of what good enough looks like, right? And that's on the CVE program to sort of determine what that minimum standard should look like. And I think it should be the Goldilocks of, you know, not too onerous, not too lax, but just right, so that you know, that objective of making them usable in aggregate to users wanting to use the records for remediation purposes is being better served. Because at the moment, yeah, I've not run any sort of analysis over how it breaks down by volume as to how many records originating in CVE5 in the CVE list have that or not. I've done a little bit of poking around by CNA to sort of see which CNAs are doing it well and give them a big sort of shout out. But there's an intersection between CNA by volume and CNA by quality, right? And so I think there's a few CNAs that if they upped their minimum quality standard, you'd drag along so much of the CVs by volume that, you know, you bring the laggards along behind them eventually, right? Or it's just making such an order of magnitude improvement in the situation straight out of the gate.
So our friend remote, Weichselgartner, clarified you might not have heard of VS package because it's a Microsoft thing. Maybe an opportunity to explore, but he really cares about Conan.
Noted. We are not anti-Microsoft. We are
Right.
open source.
But you might not watch them as closely.
Yeah, like we're a small team and we are very biased by our own development practices and our own experiences and our own sort of, you know, so yeah, like one of the things I love about coming out to things like this is I get to sample a whole bunch more perspectives and take them back to my colleagues who I'm seeing in a couple of weeks, and I'll be able to say, I heard about this VS package. So yeah.
So any additional questions online or in the room? Oh, and he sent, if you're on Discord, Andrew, he sent a link to it.
Okay. I am on Discord, yes. Hi. Wait for the mic. You can, I can repeat it anyway, but you know, I like making code run around.
So you focus a lot on Git, and it is certainly the like de facto standard. Mercurial, Breezy, these things exist. And then like GitLab, other self-hosted Git. Have you explored that? Does the schema support that other stuff?
The schema supports any, oh, sorry, to read the question, what about other VCSs, basically? So the schema supports any Git URL, and the conversion code supports a reasonably representative superset of Git hosting providers, including just a roll your own, you know. More broadly, what about non-Git VCSs? At this point, no, it only supports Git, right? And that's just a case of time prioritization, resourcing. Bang for buck, you're going to get 95%, you know, for the sake of me pulling a number out of the air, you're going to get most of the open source vulnerabilities. Now, yeah, I looked at some of the CVEs that weren't converting, and you know, there's a couple of, you know, like what's SQLite is in its own thing, right? Like it's in its own SQLite hosted thing, right? So that's such a snowflake of a thing, right? And then there's a few. I'm struggling to think of any off the top of my head. I mean, it's a relevant to have in the database piece of open source software, right? It's just like it's that age old problem of prioritizing versus and there's going to be a couple of flagship pieces of software that are not in Git that we're going to need to do some work on to be able to even express in the schema, right? And yeah, you know, like I said, small team, priorities, patches welcome, 5 minutes to go, probe tells me. And yeah, so that's basically the answer to the question. Do I see a connection in my mind for people that want to leverage OpenVex versus OSV? I think it comes back to the CSAF question as well, right? Like let's come up with a, you know, in theory, they should be convertible, right? So I really want to take the theory out of these interop sort of statements and figure out that it can be done, and if not, why not? And I'm pretty confident that it can be done. It's just a case of the code's not written yet, right? So Kubernetes wants to do everything OSV native and then sort of side convert to other formats. Is that the correct summary? And am I aware of any other projects doing that? I'm not aware of any that are doing it natively in OSV as opposed to they're mastering it in something and spitting out, say, CVE5 and OSV. The one that readily springs to mind is the Python Software Foundation. They recently became a CNA and also an OSV source at roughly the same time. The other one would be curl. Those are two that I'm aware of as sort of more recently becoming both a data source for both sort of ecosystems. I'm not aware of the implementation details behind the record that we import though. So I would point you at both of those projects to sort of put some feelers out. But, you know, we've only got 20 something sources. So, I mean, you could also take a look. I mean, all of that's in the open. If you go poking around our GitHub repo, it's all there. So you could go and do a little bit of your own research if you wanted to, and sort of shortlist a set of like-minded projects to go and have a chat with. Any more remote ones? Remote inclusive? Okay.